Imagine sitting behind the wheel of a massive 40-ton commercial truck driving on a multi-lane highway. You look out of your side window, expecting to see the solid, reassuring blur of passing asphalt or a rocky shoulder. Instead, you see absolutely nothing but a terrifying vertical drop plunging thousands of feet into a dark, mist-filled abyss. You are not driving on the ground. You are driving on a ribbon of concrete and steel suspended in the stratosphere. This is the terrifying, awe-inspiring reality of the Yaxi Expressway, globally known as the Yaxi Expressway. Deep in the remote, unforgiving mountainous terrain of China's southwestern Sichuan province, engineers have constructed what many experts consider one of the most dangerous and visually staggering infrastructure mega-projects in human history. Dubbed the ladder to the sky, this incredible highway stretches for 240 kilometers. But what makes this road an absolute anomaly of civil engineering is its elevation gain. In one specific, brutal 50-kilometer stretch, the highway ascends an unbelievable 2,000 meters, or 6,500 feet, straight up into the mountains. To put that into perspective, you are essentially driving your vehicle up a ramp that is more than twice the height of the Burj Khalifa, the tallest building on Earth. For decades, navigating this treacherous region required drivers to brave narrow, crumbling dirt roads that snaked blindly along the edges of sheer cliffs. Fatalities were devastatingly common, and rock slides routinely severed entire communities from the rest of the world for weeks at a time. The Chinese government demanded a modern, high-speed expressway to connect the isolated valleys to the booming economic hubs. But the geological reality of the Sichuan Mountains aggressively rejected this idea. How do you build a massive, flat highway for heavy commercial transport up a nearly vertical mountain wall? The answer required billions of dollars, an army of fearless construction workers, and a series of gravity-defying engineering innovations that had never been attempted before. This is the full, unbelievable story of how Chinese engineers battled active earthquake zones, lethal weather, and extreme altitudes to build a highway straight into the clouds. The fundamental law of highway engineering is friction and gravity. For heavy commercial trucks to safely drive at high speeds, a highway cannot exceed a longitudinal gradient of about 3 to 4%. Any steeper, and trucks will simply burn out their transmissions trying to climb, or completely lose their brakes on the descent, turning into unstoppable, multi-ton missiles. When the engineers surveyed the route for the Yaxi Expressway, they encountered a massive, sheer mountain face blocking their path. To achieve the required 2,000-meter vertical climb without exceeding the safe 3% gradient, the highway needed dozens of miles of open space to gently slope upward. But the canyon was incredibly narrow, bordered by towering, impenetrable walls of rock. They had absolutely no horizontal space to work with. If they built a straight road, it would have been a 15% incline, a literal death trap. Faced with an impossible topographical puzzle, the engineering team designed a solution that looks less like a public highway and more like an extreme amusement park ride. They created the Ganhaisi Bridge, the world's first double-spiral rollercoaster highway. Because they could not build outward, they decided to build upward in circles. The massive highway physically loops over itself 2 complete times, suspended high in the air on towering pillars. As vehicles drive along this massive steel and concrete spiral, they continuously gain altitude in a confined space, slowly rotating their way up the mountain face while maintaining a perfectly safe, gentle incline. But building this colossal spiral presented a catastrophic weight problem. Traditional reinforced concrete is incredibly heavy. If engineers built the spiraling bridge out of standard solid concrete, the sheer dead weight of the structure, combined with the centripetal force of thousands of heavy vehicles constantly driving in circles, would have caused the towering pillars to buckle and collapse under their own mass. To solve this, they pioneered a completely new construction material technique: concrete-filled steel tubular columns. Instead of pouring solid concrete blocks, they erected massive, hollow, cylindrical steel pipes and pumped them full of high-strength concrete. The outer steel shell provided immense tensile strength to stop the concrete from cracking under pressure, while the internal concrete prevented the steel from buckling under heavy loads. This hybrid design slashed the overall weight of the bridge by over 50%, allowing this incredible, gravity-defying spiral to float gracefully above the valley floor. As if conquering sheer vertical cliffs and designing roller coaster bridges wasn't enough, the Yaxi Expressway project faced a terrifying, invisible enemy lurking miles beneath the Earth's surface. The entire route of this mega highway runs directly parallel to the long-mentioned fault line. This is one of the most geologically violent and active seismic zones on the entire planet. In 2008, this exact fault line ruptured, unleashing a devastating magnitude 8.0 earthquake that completely reshaped the landscape. Building a massive, delicate network of sky-high viaducts and deep mountain tunnels directly on top of a ticking geological time bomb was considered an act of sheer madness. If a massive earthquake struck while thousands of cars were driving on bridges suspended hundreds of meters in the air, the massive concrete pillars would snap and the entire highway would plummet into the abyss. To ensure the structure's survival, engineers had to design the highway to essentially float above the violence of the earth. Underneath the massive highway decks, where the road meets the towering support pillars, they installed an intricate system of colossal seismic isolators and friction pendulum bearings. These function as gigantic industrial-scale shock absorbers. If a massive earthquake strikes, the violent shaking of the ground will cause the 180-meter-tall concrete pillars to sway violently back and forth. However, the heavy shock absorbers will instantly decouple the movement of the pillars from the highway deck itself. As the pillars whip back and forth, the road deck will smoothly slide and glide on top of the bearings, remaining perfectly stable and level. The highway is quite literally engineered to dance with the earthquake, absorbing millions of tons of kinetic energy without transferring that lethal force to the vehicles above. To bypass the most unstable and weather-beaten peaks, the engineers realized they couldn't just build over the mountains. They had to carve directly through them. An astonishing 55% of the entire 240-kilometer Yaxi Expressway does not touch solid ground. It is either suspended in the air on massive viaducts or buried deep within the dark, crushing rock of the earth. Drilling the massive tunnels was a lethal endeavor. Workers operating deep inside the mountains frequently encountered rock bursts, terrifying phenomena where the extreme pressure of the mountain causes the tunnel walls to violently explode inward like shrapnel. They also hit massive hidden subterranean reservoirs, triggering catastrophic high-pressure water surges that threatened to drown the massive tunnel-boring machines. Through sheer determination, advanced ground-penetrating radar, and heavy steel reinforcement, the crews carved out over 25 major tunnels, turning solid rock into a high-speed corridor. While the Yaxi Expressway conquered the vertical drops of Sichuan, another mind-bending highway project in the neighboring Hubei province showcased a completely different, yet equally impossible approach to mountain engineering. When tasked with building a major highway through a deep, incredibly narrow mountain river valley, engineers were faced with an ecological disaster. To build a standard road along the edge of the river, they would have to dynamite millions of tons of ancient mountain rock, completely destroying the pristine, old-growth forests and suffocating the river ecosystem with toxic blasting debris. The environmental cost was deemed completely unacceptable. Refusing to destroy the very mountains they were trying to navigate, the engineers made a breathtaking decision. They would not touch the mountain at all. Instead, they built the entire 10.9-kilometer highway directly in the middle of the river. Known as the Overwater Highway, this structure is a marvel of ecological engineering. Workers constructed heavy, waterproof cofferdams in the middle of the flowing river, pumping the water out to expose the riverbed. They then drilled massive concrete foundations deep into the submerged bedrock, erecting a continuous line of aerodynamic pillars that perfectly mimic the natural, winding curve of the river. By elevating the highway above the water, the engineers completely bypassed the dense forests, leaving the fragile ecosystem entirely untouched. The result is one of the most visually stunning driving experiences on Earth. Motorists cruise at high speeds on a smooth ribbon of asphalt that seemingly floats over the deep green water, flanked on both sides by towering, undisturbed canyon walls. It is a profound testament to a new era of mega infrastructure, one where brute force engineering is perfectly balanced with deep environmental preservation.
We've broken through 20 of the 25 tunnels so far. Yeah.
And the deepest section is still showing 1,100 meters down.
Keep the sounder steady at this depth. I need coordinates for that drop-off.
Got it. Logging the position now.
As you can see, the species count here is exceptionally high.
It confirms the riverine route is the superior option environmentally. The structural integrity of this ecosystem boundary is unprecedented. Look at the lichen.
And the avifauna activity remains. Turbidity is low, 1 NTU, and look at the oxygen.
Excellent. Everything is well within the natural range. The ecosystem is thriving.
The 12-month data confirms it. 0 environmental impact citation. And structural availability remains at 100%. The forest microclimate is stable.
Today, the Yaxi Expressway stands as a towering $3.3 billion monument to the absolute limits of human willpower and civil engineering. It took 5 grueling years, tens of thousands of workers, and the invention of entirely new construction methodologies to force a high-speed highway into one of the most hostile environments on the planet. But the impact of this impossible road is truly immeasurable. It has completely transformed the economic landscape of southwestern China. Remote, impoverished mountain villages that were once entirely isolated by geography are now plugged directly into global supply chains. A harrowing, multi-day journey fraught with the constant threat of lethal rock slides and plummeting cliffs has been reduced to a smooth, breathtakingly beautiful few hours of driving. These massive structures, from the double spiraling rollercoaster bridges that defy gravity, to the seismic isolators that laugh at earthquakes, to the ecological highways that float over rivers, prove that when faced with the insurmountable walls of nature, true engineers do not turn back. They build over it, they tunnel through it, and sometimes they just build a ladder straight into the sky. If you are absolutely obsessed with the incredible machines, raw grit, and insane mega projects that are physically reshaping our world, hit that subscribe button, leave a like, and tell us in the comments below. Would you have the nerve to drive a heavy truck on a roller coaster bridge suspended 6,500 feet in the clouds? See you in the next mega project breakdown.